All right, we're going to take a look at problem number 2 from the same assignment. It says a 2.5 gram sample of an isotope of strontium 90 was formed in a 1960 explosion of an atomic bomb. Big explosion. All right, this happened in 1960. And within this explosion, we formed a radioactive isotope of strontium 90. And we know that we have 2.5 grams, 2.5 grams of strontium 90. Strontium 90 is a radioactive substance, and we're told that the half-life of strontium 90 is equal to 28 years. The question here is, in what year will only 0.625 grams of this strontium 90 remain? Again, we are not told what kind of emitter strontium 90 is. Is it an alpha? Is it a beta? Is it a beta negative, beta positive? Let's assume it is a beta positive emitter. Beta positive emitter. Right. How would we complete that decay reaction? Now we need our periodic table. Strontium, which is just about right here, halfway down the second column of the periodic table, is 38 protons. If this thing is a beta positive emitter, then the daughter nucleus would have to have 37 protons in it, 37 being rubidium, and the mass of that rubidium would be 90. Again, I could just add the bottom numbers. They have to be equal on both sides of the arrow. So 38 on this side, 1 and 37 is 38. Same thing with the masses. Now we're also going to be forming a neutrino in this reaction, but a neutrino has no charge nor any mass, so it doesn't affect these numbers here at all. Anyway, as the strontium 90, which was produced in this explosion, exists in time, the strontium decomposes into rubidium. So the strontium amount goes down as the rubidium amount goes up. Now we're told that this sample, this 2.5 gram sample, gets cut in half every 28 years. I'm going to start out with my original 2.5 gram sample of strontium 90. 28 years later, it's going to be smaller. Half of that, as a matter of fact, every 28 years, it's cut in half, so this is 1.25 grams. Another 28 years go by, another half-life, and this gets cut in half again. Well, what's half of 1.25? It's going to be 0.625 grams. It's even smaller. Now this is as far as we need to go. Go back to the problem, and they want to know in what year will only 0.625 grams of strontium 90 remain. Well, this amount is hit after 2 half-lives. 2 T1 halves go by in order to get from 2.5 grams to 0.625 grams. So that's a total of 28, and 28 is 56 years. So, if this original explosion took place in 1960, what would our date be 56 years later? 1960 plus 56 years later, 2060. year would be 2016, that is the answer right there.